Adding and subtracting rational expressions. Rational expression is an expression, so no equal sign, and rational means fractions. So for example, we have 3x over x plus 4 plus 12 over x plus 4. So whenever you try to add or subtract fractions, you first need to make sure that you have a common denominator. In this case, we have x plus 4 as the denominator for both of our fractions. So we have a common denominator, so that's a good first step. If you have a common denominator, that means you can just add your numerator. So that gives us 3x plus 12 all over x plus 4. But you're not done. You need to look at this and see if there is something that you can factor in order to simplify. So looking at 3x plus 12, well, that will factor. In common between 3x and 12 is a 3, so I can factor out a 3, and that'll give us x plus 4. Well, I had x plus 4 in the denominator, so what that means is x plus 4 and x plus 4 will cancel, and this will simplify to just 3. Let's try another one. X cubed minus 12x squared plus 45x all over x times x minus 8. And let's subtract x squared plus 5x all over x times x minus 8. So we have a common denominator already, so that's good. That means we can just perform our subtraction in the numerator. So here we have x to the third. I don't see any x to the thirds over here, so that'll just stay. Here we have negative 12x squared minus x squared. So negative 12x squared minus x squared, that's going to give us negative 13x squared. Then we have 45x minus 5x. So 45x minus 5x, that is going to give us 40x. And that is all over x times x minus 8. Well, look at that numerator. Let's clean that up a little bit. We can factor out an x, and that'll give us x squared minus 13x plus 40 all over x minus 8. Well, let's see if we can clean it up a little bit more. Well, does this factor? I need two numbers that multiply to 40 and add to negative 13. It'd be really convenient if one of them was this minus 8 right here. So let's try that first. Well, 8 times 5 is 40, so I think we have a winner. 8 times 5 is 40. A negative times a negative is a positive. Negative 8 plus negative 5 is negative 13. So now we need to look for the numerator and the denominator and see what will cancel out. So in our numerator we have an x, denominator we have an x. X minus 8, looks like our whole denominator cancels, and all that we have left over is this x minus 5 right here. So this whole thing simplifies to just x minus 5. Now these past examples have all had a common denominator already, but you don't always have a common denominator. So let's look at some cases where you don't have a common denominator. For example, 9 over x squared plus 3 over 2x. So I don't have a common denominator here. I need to make a common denominator. I need x squared and I need 2x to both be represented in the denominator. So in order to get a common denominator, this one needs this 2. So I'll multiply top and bottom by 2. This one needs an x, so I'll multiply top and bottom by x. That will give me a common denominator of 2x squared. So 2 times 9, that gives us 18. 3 times x, that gives us 3x. So now we can simplify. So we have 18 plus 3x in the numerator, and we have 2x squared in the denominator. Let's see if we can clean this up at all. 18 plus 3x, that has a common 3, so that will give us 6 plus x over 2x squared. So while we were able to factor out that 3, it doesn't let us cancel anything. So these are equivalent forms, and that would be done. Let's try again. Seven over 4xy to the third plus 1 over 6x to the second y. Well, I need a common denominator. Well, I have a 4 and I have a 6. So the best number for 4 and 6, we could use 12. You could also use 24. You could use a lot of different things as long as it is a multiple of 6 and a multiple of 4. But 12 will work, so why don't we use 12? In order to make 4 12, I need to multiply by 3. So I'll do that top and bottom. In order to make 6 12, I need to multiply by 2. So I'll do that top and bottom. Let's check the variables. I have x to the second here, so if I want x to the second on both sides, I also need to multiply this side by an x. I have x to the second, so I don't need anything over here. Here I have y to the third, here I only have y. So if I want to make this y to the third, I need to multiply top and bottom by y to the second. Alright, let's see what we have when we clean this up some. X times 3 times 7, well 7 times 3 gives us 21. Usually you see the x on the other side, so I'll move that over. 3 times 4, there's our 12. X times x is x squared, y to the third. We have our plus. 2y squared times 1 is 2y squared. 2 times 6 is 12. We have x squared. Y squared times y is y to the third. Now I have common denominators. So that means I can add in my numerator, so 21 x plus 2y squared, and put that all over my common denominator of 12x squared y to the third, or y cubed. It doesn't look like there's anything I can factor out of the numerator or the denominator, so that would be finished. Let's try again. Two m plus 9 all over m minus 5 minus 4 all over m squared minus 3m minus 10. There we go. So let's see what we can do here. Well, let's factor first to see what we're working with. So if we factor this, I can factor this to be m minus 5 times m plus 2. Two numbers that multiply to negative 10 add to negative 3. There we go. Notice I have m minus 5, m minus 5. So the denominators are pretty similar. If I had an m plus 2 in this one, then I would have common denominators. So let's multiply this by m plus 2 and this by m plus 2. There we go. We already have the denominator here factored, so that's convenient. And now we can simplify in the numerator. So I have m plus 2 times 2m plus 9 minus 4 all over m plus 2 times m minus 5. Now it is really tempting to cancel these m plus 2's, but you can't do that because of this minus 4. That minus 4 is throwing us off, so we're not able to cancel. Before we can do anything, we need to clean this up and see if we can refactor to then be able to cancel. So cleaning up right here, we need to FOIL these two pieces. If we FOIL, we get 2m squared plus m times 9 is 9m. 2 times 2m is 4m. 2 times 9 is 18. Now let's clean it up. 2m squared. 9 plus 4 is 13. 18 minus 4 is 14. all over m plus 2, m minus 5. 2m squared plus 13m plus 14, that's not going to factor to give us an m plus 2 or an m minus 5, so that would be our simplified form, and that would be done in this case. Let's try one more. There we go. So let's look at those denominators. They're similar, they have some common parts, but not quite the same. And so in order to do our subtraction, we need common denominators. They both have a p plus 4, so that's good. This has a p minus 4, so this one needs a p minus 4. This has a 2p minus 3, so this one needs a 2p minus 3. Now we have common denominators. So whatever you do to the denominator, you have to do to the numerator so that you keep it with a multiplying of a value of 1. So that means I need to multiply p minus 4 here, and I need to multiply 2p minus 3 here. Now we can simplify it all down. So while we multiply this all through, how about we do some distribution? So here we have 2p minus 8 minus, now be very careful, we're distributing a negative 3 here. So that gives us negative 6p, and then we would have a negative 3 times a negative 3, that's going to give us plus 9. All over our common denominator, there we go. Now let's clean up our numerator. 2p minus 6p, that gives us negative 4p. Negative 8 plus 9, that gives us 1. Nothing changed in our denominator. There we go. Negative 4p plus 1, that does not factor, so there's nothing that we're going to be able to cancel if we were to keep going, so that one is done.